All right, so welcome to part 2 of our graphing quadratics in standard form. This is still for our Tuesday, April 21st lesson, or you can, of course, get started on it earlier than that. So let's go ahead and look at the problem. The hardest thing about these problems, the biggest pain in the behind is having to make the graphs, okay? If the graphs are pre-made for you, I think you're going to see that the steps are fairly easy to do, okay? And we know that there's some substitution and plugging in, but I'm also going to show you how you can get to a quicker version of the answers in this piece right here. Okay, so let's go. Before we graph this problem, okay, I wanted you to notice this part right here. And so remember, whenever you're going to make a graph or whenever you have to copy the problem down, if I'm going too fast or whatever, please just pause the video, get it all down, and then we'll connect again. So let's look at the last problem we did from part 1. You remember we plugged our numbers in and we did our graph. But I want you to notice something about our answers here. Not only were they symmetry, I want you to see this. Take a look at that, is that when we went to the right one, our first value also went up 1. Okay? And then look what happens here. We're going to go up 1 again. And that's going to go 3. And it's going to do it on the top part of our table and the bottom part of our table. And this happens every time that A is 1 or negative 1. See, the only difference between A being positive is this is A being positive and this is A being negative. The vertex stays the same, so it's just positive and it's negative. And so every problem we do where A equals 1, we can make the table without substituting in. And so that's what I'm actually going to show you starting on these examples is this part right here. So we're just going to kind of call this 13, which means we go 1 and 3. Okay, so we go out 1, up 1, out 1, up 3, and you'll kind of get to see it in the example right here. But of course, we can't make a table. Okay, we can't make a table until we know something about this right here. So I'm going to show you these 3 steps right here. Of course, some of these steps you're not going to find to be absolutely necessary, but I like to include them in each problem just so I stay organized. I don't like to look back at the original, so I kind of like to record my numbers down. So we know from the quadratic formula, you're used to identifying A, B, and C. And we're going to find we really don't need C in this problem, but it's just a habit that I've gotten myself into. Okay, step 2. Will my parabola go up or down? And so based on part 1, your A value determines whether your parabola goes up or down. So I look at my A value, and since A is positive, and remember, instead of writing A as positive, we can write A is greater than 0. That means A is positive. We know that we have a parabola somewhere here that is going to shoot up. Okay, here's the part where we really start doing our work. we need to find that imaginary line because our vertex sits on that imaginary line. We have no way of knowing where our vertex is. It is not at 0, 0 anymore. We've put a lot of stuff back here. So when y equals x squared, when there's b is 0 and c is 0, this is going to be my vertex. My vertex is no longer there. So I need to show you guys and teach you guys about these next sections. We're going to find our axis of symmetry, which helps us find our vertex. So here we go. Our vertex, the axis of symmetry, is x equals negative b over 2a. Remember, x equals is going to be the vertical line. You might remember negative b over 2a kind of from the quadratic formula. X equals negative b plus or minus the discriminant all over 2a. So it's almost like the front half of that. So I'm going to plug in and notice that it's a negative, but my b is also negative. So just like when we're plugging into the quadratic formula, you need to be careful about watching your signs. So I'm going to simplify the top. And our axis of symmetry is x equals 3. Now, I don't know if you've made your graph yet, but if you haven't, you can pause the video and make your graph. And mine are about 6 up, 6 down, 6 left, 6 right, sometimes 7 up, 7 down, 7 left, 7 right. But you can kind of get away with that right there. So if you don't have any graph paper, just make a very nice graph, find a ruler, find a straight edge, and make your points evenly spaced apart. Okay? So if you haven't done it, pause the video and go ahead and do it now. But I'm going to go ahead and continue. Okay, so the axis of symmetry is x equals 3. So I know my parabola is somewhere sitting. We know it goes up, and so it's somewhere sitting on this right here, but I don't know where my y value is. Well, that's where the vertex comes in. So I'm going to call this step 4. And so my vertex is 3 comma question mark. So we get our vertex. So this is why you have to do the axis of symmetry. The axis of symmetry gives us the x value. And then what do you think we're going to do? We're going to go ahead and plug in and solve for y. So we're going to plug in and do order of operations. And since most of you have a calculator, you'll be able to just kind of type it all the way in and hit your equal sign and have your answer. So that's what we're going to do. So notice I'm going to say y equals 3 squared, should always protect with parentheses, especially when x is negative, minus 6 times 3 plus 5. And so whether you punch this in the calculator, whether you do each piece, I get 9 minus 18 plus 5. But we should all come out with y equals negative 4. My vertex there is my vertex, 3 comma negative 4. okay? So there is my, I know I have a parabola going like this. I don't know what points it's going through, okay? But I know the center of that. So now I'm kind of ready to make my table. So let's get our table ready. So we set up our table and we put the vertex in the middle. Don't put it at the top, because remember, we need to find the shape we have going here. And so what you could do is you could plug 2 into the calculator and get your answer. And then you can match it, and you can put 5 or 1 in the calculator. But if you go back to the system, okay, if we did these problems over and over again, you would notice the same thing. So if you add 1, -4 plus 1 would be -3. And because of symmetry, we would have the same answer. So just to show you, 2 squared is 4, minus 6 times 2, which is 12. So 4 minus 12 is -8. -8 plus 5 is -3. We're going to get to the same spot. Okay, so we're going to pretend that we can all plug this in, but we're going to take the shortcut. Now here, we add 3. Okay, don't say -6. -3 plus 3 is 0, and of course we would have a 0 right there. So let's plug in. Let's go ahead and plot our points. So we've finished our table. So you can plot your points while I'm kind of doing the same thing. And so my graph's a little off, but that's okay. We're going to go ahead and finish our graph out. Whoa. And we have graphed the parabola for y equals x squared minus 6x plus 5. So what you've been doing with all these trinomials and all these quadratics over the last few weeks is you've done everything but except grab a picture of it. Okay? And so I'm going to do a few more examples with you in some of the other parts so you can see kind of a variety of things. But there's one thing I want to do before I end part 2. I want to focus on these 2 points right here that are on the x-axis. And I want you to remember the x-axis is also where y equals 0. So just a few weeks ago, I was having you factor trinomials, and then we said we're going to solve, and we set them equal to 0. And you would have factored this, you would have made your diamond, or you could have done the quadratic formula, and you would have said x minus 5 times x minus 1 equals 0. Set our binomials equal to 0. And your answer would have been x equals 1 and x equals 5. And of course, you were putting that on your paper and not even knowing what that is. Oh, you knew what it was. We kept telling you that if you put 5 and 1 into here, you would get a true statement. But here's what you're actually doing that you did not know. Look at 1 and 5, and where does our parabola cross the x-axis? 1 and 5. The value of x when y equals 0. So whenever you are solving a quadratic, you are actually finding where your graph crosses the x-axis. And that is going to be really, really important in IM3 next year for you to make that connection. There's a lot of different graphs out there, but they're going to ask you to find the zeros in a problem. And so you're going to be using this type of information next year. Now right now, I just want you to really practice graphing the parabolas, and I would love for you to make this connection. And I think that's probably one of the biggest things about not being together, is that I really don't have that time to try and connect this all together. So let's end part 2 with this example, and let's sum it up real quick. I asked you to graph y equals x squared, and we said a equals 1. And I showed you that all parabolas have a pattern. And so when a is 1, and I'll show you in the next example when a is negative 1, it goes 1, 1, and then it goes 1, 3. And the answers on top are the same as the answers on the bottom of your table. Or you could kind of go out like this. I kind of like to do this. Let's go out 1, up 1, out 1, up 3. It's the same thing every time. Here, here, and here. And when we go down, it's going to be here, here, and here. That is going to be the shape in our Tuesday work. Thursday video, the video after Thursday, we'll start changing the A value and kind of doing some different graphs. But this Tuesday, April 21st videos are you just getting used to graphing a parabola or a quadratic when a equals 1 and when a equals negative 1. I'll see you in part 3.